All right, folks, number 9 and number 10 on the concept list both talk about tangent lines to a particular curve. So they're giving you an equation, and you're expected to write the equation of the line tangent to a given point. So the first thing is to understand when we're talking about an equation of a line, the most common form of a line is mx plus b, which is slope-intercept form. The m is your slope, the b is your y-intercept. But you're actually going to have to use point slope form to get there. And that's the y minus y1 equals m, the slope times the quantity x minus x1, where your y1 and your x1 are the coordinates of an ordered pair that you have. Okay, so what we're going to do first of all is talk about this ordered pair. They're going to give you usually just the x value of that ordered pair, and what we're going to do in the first step is find the y value of that ordered pair. So you're just subbing in for the value they give you. Okay, so that's 0 squared is 0, 3 times 0 is 0, and plus 2 gives you 2. So your ordered pair that we're working with for this problem is 0, 2. That's step 1. Okay, step 2, okay, now that we have our ordered pair that we're going to be working with, is we need to know the slope. And the slope, by definition, can be found finding the derivative of the function and evaluating it at the x value we're given. So step 2 is our slope, which is just the derivative of our function at the x value given. So now we're going to use our power rule. Okay, the x squared, the 2 comes in front, so that's 2x, power decreases by 1, 2x to the first. Okay, here power rule again is plus 3, and that x to the 0 disappears. Okay, so this part plus 2 constants go away. So there is your slope formula. So now we were given x equals 0, so we're going to just plug in 0 there and find the derivative at that value. So 2 times 0 plus 3 is 3, so our m value is 3. Last step is put it all together in your formula. So y minus y1 is y minus 2, okay, from up here, and then equals our 3, and then x minus this 0. Simplify through here gives you y minus 2, distributing is just 3x. Add that 2 over, and we get y equals 3x plus 2. That's it. Okay, exact same process on the next one. Okay, we're going to first substitute in to get the value. Okay, this time they gave you the value 1. The square root of 1 is 1. Okay, here, 1 squared is 1. And then just simplify. So we've got 4 times a negative 4 is negative 16. So your ordered pair was 1, negative 16. Okay, step 2 is we're finding the derivative. Because it's set up as two quantities being multiplied, the easiest way to do this is product rule. Okay, so I do the derivative of the first part. So that's our 1/2 x to the negative 1/2 power. Okay, I like to use the power rule on this. I know that you can simplify using the square roots, but sometimes this is easier to work with as you substitute in numbers. Okay, then times the second piece plus derivative of the second piece is 2x times that square root of x plus 3. Okay, so there's your slope formula, but we just have to evaluate it at the given x value. So we're just plugging in those numbers. Okay, so here what I'm going to do is change this back now. Okay, and hopefully you've gotten to a point where you're recognizing that there is a shortcut with the square root of x. It's just 1 over 2 square roots of x. Okay, but if you're not there, power rule always works. 1 is there, so this part is just 1 over 2. Okay, 1 squared is 1 over here. 2x is 2 times 1. Square root of 1 is 1. And then we're just simplifying. Okay, so 1 minus 5 is negative 4. And of course you could throw this in your calculator, but I'm just simplifying as I go here. And this would be negative 2 plus 8, which is 6. So it's giving me a slope of 6. Remember that's your m value. And the very last step is just putting it in your y minus y1. Looks like y minus a negative 16 is plus. Then your 6 times x minus 1. And then distributing through. So y plus 16 stays. This is 6x minus 6. Subtracting your 16 over. So y equals 6x minus 22. And that's it. Okay, I'm going to go ahead and talk about the second part with your tangent functions since they're related to the same topic here. This one says a horizontal tangent. So this is saying literally a slope of a horizontal line, which means it's essentially a slope that's equal to 0. We decided on the last one that the slope formula is the derivative, so this process is just asking you to find the derivative and set it equal to 0. So some of this is going to require us to solve quadratic equations. Okay, so that is something to be careful of. So as we're going through here, the first one, we need to find the derivative using our power rule. That looks like 2x plus 3. We're just setting that equal to 0. So I'm just substituting directly. Okay, so we're subtracting that 3 over, dividing that 2 over. So x is negative 3 halves, and that is it for that one. Okay, it's just derivative equal to 0. Second part, okay, this is a quotient rule. So remember we're doing derivative of the first one, so that's just 1, times the second thing, minus the derivative of the second thing, so that's 2x, times the other one, all divided by the bottom squared. Okay, so for this one, what I'm going to have you do usually for these is actually simplify. The last one I didn't bother simplifying. It's going to help us here a little bit if we can at least make this top part look better. Okay, we can do that by just distributing through. This first piece, 1 times anything is the anything. So I'm just writing this x squared plus 4. And then over here we've got minus 2x squared and then plus 4x. Okay, but the reason we're doing that is so we can see what happens, and I missed my squared here, so we can see what happens when we set this thing equal to 0. Okay, so I'm going to go ahead and simplify one more before I do that equal 0. So x squared minus 2x squared is negative x squared, and then I'll just write this plus 4x and this plus 4, just bringing it down. And then this whole thing, there's no real need to ever expand those out for quotient rules, and I'll show you why. Okay, we're setting these equal to 0, so if we're trying to solve this thing, we would want to multiply this whole denominator over, including the power. And when we do that, on the other side we get a times by 0, and 0 times anything is 0. Okay, so we don't need to spend time expanding that out because it's going to go away anyway. Then on this part, we've got this negative x squared plus 4x plus 4 just coming down. So a couple things that you can do when you have a quadratic equation. One is you can try to factor. And I'm going to always have you look for a GCF if you can, regardless of the method you want to use to solve. And then the other methods you can use to solve are quadratic formula or this thing called completing the square. And if you've never heard of that, don't even worry about it. Quadratic formula will work for every single problem. Okay, so we're going to look for a GCF regardless of which method we use here. Okay, what I'm going to recommend you do, when you see a negative here, I honestly would rather you just divide it out because I like my first number to be positive. So that'd be x squared minus 4x minus 4 equals 0. Okay, it's nice to have that positive. Okay, then if we were to try to factor, now we can say x times x, and we're looking for factors of negative 4 that add to be negative 4. Well, unfortunately, that's not possible. So this one's not factorable, which is why you saw your answers on the answer sheet look pretty ugly. Okay, so this would be the time where you would use quadratic formula or you would complete the square. Now this is actually one that's really nice to complete the square on, but quadratic formula is the most common way to solve this, so we'll talk about that. Okay, so our formula for this is opposite of b plus or minus b squared minus 4ac, all divided by 2a, where this number in front that we see 1 here is an a, this number in front here, the negative 4, is our b value, and this constant, this negative 4, is our c value. So the opposite of b would be the opposite of negative 4, is 4. B squared would be negative 4 squared, which is actually a positive 16. Careful there. And this is 4 times a, which is 1, times c is negative 4. All divided by 2 times a, which is 2 times 1. And then we just go to work on simplifying here. So to simplify, we're going to try to break down this first. This says 16 plus 16, so that's the square root of 32. And then 2 times 1 is 2. So this we want to simplify by finding a perfect square that goes into 32. And the biggest perfect square that goes into 32 is 16. We're saying 16 times 2 is the same thing as 32, but this makes nice things happen. So we've got 4 plus or minus, square root of 16 is 4, square root of 2 stays put, divided by 2. And our very last step here is all of these numbers, we can divide that 2 out. And we got 2 plus or minus 2 square roots of 2, and that's your final answer here. Okay, so they use the square root of 8, but more commonly we want to break that down all the way, so it's actually a little bit off for that answer. Okay, if you're interested, and this is only if you're interested, if you're good with quadratic formulae, stop the video now. I'm going to show you completing the square because it actually is a lot faster for this problem. When I say completing the square, I mean completing the perfect square trinomial. So right now, this is not a perfect square trinomial because this negative 4 is not a perfect square. So if I want to complete this perfect square trinomial, I need to put in a perfect square here and move that negative 4 to the other side just by adding it over. Okay, but if I'm going to add in a number here, I have to do it to both sides to make the equation balanced. This number is always the same. It is found by taking half of b, so this number, and squaring it. Because that, if you square something, it's always a perfect square. So taking half of b, that would be negative 2, and squaring it, you get a positive 4. Okay, then we can break this down as something squared, because perfect square trinomials can factor. It's into square root of this, square root of this, and the minus comes down. Over here, 4 plus 4 is 8. And then we can take the square root of both sides. So these cancel, leaving x minus 2. The square root of something is always plus or minus, but what they failed to do is simplify this. We again want to break this down into a perfect square, 4 times something. And then that's really 2 square roots of 2. And then last step is just adding that 2 over. And they're equivalent. Okay, this process, while it takes a little bit of getting used to, is often faster than quadratic formula because quadratic formula you have to usually break down and reduce, whereas this one you just have to break down, you usually don't have to reduce. Okay, so just to show you that. Otherwise though, remember when you're talking about tangent lines, it's just the slope, it's just the derivative. When it's horizontal, that's when you're setting it equal to 0.